Hey guys, today we're going to talk about surface area of a new shape, the triangular prism. Well, not new shape, but new for surface area. So lesson 10-4, surface area of triangular prisms. Oh, I did a capital. I didn't do a capital. There we go. And today is May 2nd, 2019. So before we begin, we're going to do a little Venn diagram, kind of a core style of comparing rectangular prisms to triangular prisms. So, get myself fairly big circles here. Actually, I want to get even bigger. Just fill up my whole screen. How about that? So these are going to be your rectangular prism on the left. And a triangular prism on the right. Now we're going to add a couple things in each of the categories. So if you're doing this on your paper, make this about half of the page, maybe. Okay, we'll see how it goes. So let's talk about things that they have in common. So we've talked about how, you're right, I heard this one, they're prisms. That means they have two congruent parallel bases, okay? They're three-dimensional. That's another part of being a prism, is it has 3 dimensions instead of 2, like we studied in Chapter 9. But probably the most significant one is all the sides are rectangles. So rectangle sides. So when we do surface area, we're going to be calculating area of rectangles no matter what the base shape looks like. Okay? So let's talk about rectangular prism. Well, let's see. If you think about it, there's 4 corners to our rectangular prism, and we're going to call each corner a vertex. So 4 vertices. So those are the points where the edges meet. Okay? So point where edges meet. It has 6 bases. So when we were building our own rectangular prism, we had 4 in the middle and 2 side flaps. We have 4 rectangular sides. So that makes it unique from a triangular prism. Okay. Yes, it has rectangular sides, but this one has 4. It does have a rectangular base. Okay, that's definitely going to be, in fact, there's 2 of them. 2 congruent rectangles. Okay, let's see. And then there's, when we were looking at dimensions, we had 3 sets of congruent sides. So that meant we had a front and a back that were the same, a top and a bottom that were the same, and we had 2 sides that were the same. So we're going to say 3 sets of congruent sides. And I'm going to say minimally. That's in the case where all the dimensions are different. If we have 2 dimensions that are the same, then we're not going to have 3 sets of congruent sides. We would have 2 sets. Okay, and that happened on some of your prisms with nets that we turned into prisms, is that we had 4 sides that were the same and the 2 flaps were different. Okay, and then if it was a cube, we would only have, or I'm going to change that word. It's not minimally, it's maximally, isn't it? Yep. maximally. So there's no more than 3 sets of congruent sides. Okay, maximally. So if it's a cube, all the faces have the same exact area. They're all congruent. All right, so let's talk about the triangle. How does he differ from the rectangular prism? Well, let's think about it. There are 6 vertices. A triangle has 3 sides, so you've got the 3 points on the front base and 3 points on the back base. Strangely enough, it only has 5 faces. And if you think about it, because a triangle has 3 sides, those are going to be the 3 rectangular faces of your prism, and then you have the 2 bases. This shouldn't be so. Well, we're going to have 3 rectangular sides. I kind of match these one for one. 3 rectangular sides. We have a triangular base. In fact, we have 2 congruent triangles. Okay. And then what gets a little bit strange is how many sets of congruent sides. There's only 1 set of congruent sides guaranteed. And that would be the bases, right? Now, it is possible if my triangle has 2 sides that are the same, which is called an isosceles triangle, it is possible I'm going to have 2 rectangular sides that have the same, that are congruent. If I have a triangle that all the sides are the same, that's called an equilateral triangle, then I could have all the sides would be congruent, and then the bases would be congruent. So there you go. All right, so let's talk about formulas. I'm going to go to my next screen. So formula for the area, or formula for surface area of triangular prisms. So we gotta first think about what we know about a triangle. So we got the area of a triangle, and that's going to be A equals 1/2 little b little h, where b is the length of the base. And little h is height of the base. Okay. Now, I'm going to draw a net, and I'm going to tell you right now, I don't like drawing nets. Okay, so we're going to, when we solve the problems, we're going to talk about it more as a triangle train, okay, because there's going to be a train of sides that we're going to be doing. But I'm going to do it once just so you can see it. And we're going to talk about, you know what, I'll be honest with you, you will learn about a formula for surface area, but not until geometry. For our purposes, we can just kind of come up with our own way of doing it. So I'm going to give you an example. Let's see. Boom, boom. Okay, so let's put in some dimensions. He's 5 centimeters, 12 centimeters at the bottom. Over here, we've got 2 centimeters, and then we've got 13 centimeters. Okay, so we're going to have more information about a triangular prism in order to figure out its surface area. So if I took this guy and I flattened him out, I'm going to see 3 rectangles. again, don't really pay attention too much to my dimensions here because, oops, I'm going to have to move him a little further down because I'm kind of lame, as you well know, about doing these guys. That's why I should have had my graph paper, huh? Okay, so I have triangles, and in this particular case, they're 3 different sizes. Why? Well, because my triangle has 3 different lengths. So I'm going to make these a little brighter. This one is 5. Here's your 12, and here's your 13. Okay, so those are going to be the lengths of my rectangles because they have those, that's the dimensions of the triangle, okay? Now, if you notice, we have a height is 2, and that's going to be everywhere else, okay? Now, what about those bases? Well, I can put them anywhere, but I'm going to put them right here. Well, not anywhere, but I had 2 choices. Okay, now if you look back here, I'm going to highlight him. Okay, my right angle is the 5 centimeter and 12 centimeter. Notice what I have here: 5 centimeter, 12 centimeter, and those are right angles, right? Because they butt up to a rectangle. And then this is a 5, and this is your 12 is over here. Okay? So, oh, and by the way, let's put in those other numbers. 13's here, and 13 is here. Okay. So, instead of coming up with a formula, we're going to kind of write it down as figuring out the area of each face. Okay, so one thing we should notice is we have 2 triangles that are identical. So if I figure out the area of one triangle, double it, I'm good. And then I have 3 rectangles. Okay, so this is my train of triangular prisms. So these are the sides. I've got a double engine up in front, and I've got 3 cars behind it. Okay, so what I'm going to do is figure out from this shape, I have 2 triangles, and the area of the triangle is going to be 1/2 the base of the triangle, so this is going back to our original shape, 12 times the height of the triangle, which is 5. And then I'm just going to pair up each triangle dimension with the height of the prism dimension, okay, that 2 that I've circled in orange. So I'm going to have a 5 times 2. I'm going to have a 12 times 2. And I'm going to have a 13 times 2. So each of the dimensions of the triangle is going to be multiplied by the height of the prism to figure out the areas of those rectangles. It works that way every single time. So just going to do the math here. This is one big product in the beginning, so 2 times 1/2 is 1. So I'm left with 12 times 5 is 60, plus 5 times 2 is 10, plus 12 times 2 is 24, plus 13 times 2 is 26. And I just add up everything that I have. I've got 70, and 24 and 26 is 50, and that gives me a grand total of 120. Now I do have dimensions, and because this is area, it's going to be squared. So the answer is 120 squared centimeters. Okay, we're going to do 2 more examples, and again, I'm not going to draw the net, I'm just going to do my train, okay? So directions are going to ask us to find surface area. Of each triangular prism. Okay. So they may give us our triangular prism written out, but we don't have to net it out. We just need to find the information and go from there. So I'm going to put my numbers in color. So this is a 1 inch, this is a 1 inch, this is a 1 inch. So we're going to have to be given what the lengths of the sides of the triangles are. Sometimes they're going to do it in the front, sometimes they're going to do it partially in the back, but remember, since the 2 bases are congruent, we just bring it in. And then here is going to be the height of the triangle base is 0.8 inches. Okay, and then we are given this is 15 meters. Okay, so I'm going to go ahead and draw out my frame of 2 triangles plus, and if you notice, every dimension of the triangle is 1 inch. 1 inch, 1 inch, 1 inch. So we call that an equilateral triangle. So we're going to get 3 rectangles that are exactly the same. Now, you don't have to be that specific when you're drawing the picture, but just keep that in mind as we're going through this. So let's write down, so we know these are all the same. Why? Because we have an equilateral triangle. Okay, so let's start building out what we know. So we're going to have 1/2 the base of the triangle times the height of the triangle. And then, oops, sorry, that should be black. And then I'm going to put some 1, 2, 3. And then we're going to do the areas of those rectangles. So let's see, 1 by 15. On the left side, 1 by 15. On the bottom, 1 by 15. Bingo. Pretty nice, huh? And then we just solve. 2 times 1/2 is 1. 1 times 0.8 is 0.8. And then we have 15, not once, not twice, but 3 times. Okay, so we can do that quickly. Oops, sorry, that's supposed to be plus. 3 times 15, that gives me 0.8 plus 45. And my answer works out to be 45.8 square inches. That's my surface area. Okay? Simple as that. Now, if you recognize you have all 3 of the sides are the same, or even if you have 2 rectangles that are going to be the same, I'm going to just show you off to the side here. For this piece, instead of writing what we did here, we could say 3 times 1 times 15. Okay, and then just cut to the chase that way. All right, let's do one more. And this is what the triangle looks like. And this is 6 meters. This is 10 meters. This is 13 meters. And this is 16 meters. Okay, so let's look at the triangles. It's another way to kind of So the dimensions of my triangle were a 6 by 10 by 13. Okay. So what I'm going to do is for each one of them, I'm going to multiply by height of the prism. That's your number 16. And that's going to be my 3 rectangles. Three rectangular sides. It's as simple as that. Oops, sorry, no S on that one. There. Okay, so that's what we do is we take the triangle's dimensions, we multiply them by the height of the prism, and those are going to be your 3 rectangular sides. All right, so we start off again with our basics. We're going to get 2 triangles plus a rectangle plus a rectangle plus a rectangle. So we're going to get 2, and we're going to get 1/2 the base of the triangle, which was 6, times the height of the triangle, which is 10, and then we're going to have 3 rectangles. So the first one is going to be 6, and we're going to multiply it by 10, or by 16, excuse me. And then the next dimension is going to be the 10, and we're going to multiply it by 16, height of the prism, and then we're going to take the last one, which is a 13, and we're going to multiply it by that 16, the height of the prism. Okay, now, unfortunately, this one isn't the same, right? We're going to have to do some calculations. Life goes on. So, this is our surface area, and we get 2 times 1/2 is 1, 6 times 10 is 60. So off this side, I'm going to do 16 times 6. So I get 36. I get 96. And I don't have to do it for this one because you multiply by 10, you just plop on a 0. So 10 times 16 is 160. But I will have to do it on the last one. So we get 18, 4, placeholder, 6, 1. So we get 208. Okay, and then we just add up. And let's see what we get. First 2, I'm going to add, I'm going to get 150. Oops, sorry, try that again. 156. And the second 2, I'm going to add, and I'm going to get 368. So off to the side, I'm going to add those together. And I get the surface area of this triangle is, or triangular prism, is 524 square meters. Okay, so the sides of the triangle each get multiplied by the height of the prism. Okay, all right, good luck with this, guys.